All right, so the first question we'll take a look at is graphing a multi-step transformation. The only tables you're going to have to create by hand are for sine and cosine graphs. So first one we have is 3 sine x plus pi minus 2. First, how many transformations are in that one? Yep.
3.
Yep, there's 3 transformations. So what we need to do first is make the original table. We'll start with those values, and then we're going to modify them all for this transformation. Okay, what are my original x values for sine? Yep.
0, pi over 2, pi, 3 pi over 2, and 2 pi.
2 pi. Okay, so those are my original x's. Inside here, I'll put all my final answers. And then, what are my original y values for sine? Yep.
0, 1, 0, negative 1, 0.
0. Okay. So those are my y's. Now, the first thing we have to figure out is, out of the 3 transformations, which value, the 3, the pi, or the minus 2, is going to affect the x's? Yes?
The plus pi.
Yep, the plus pi. That's going to be a horizontal shift. Everything is going to move to the left pi units. So what should I do to all of these values with pi?
Subtract pi.
We're going to subtract pi. So we subtract pi from all of them. First one is negative pi. What's the second one? Yep.
0.
That's the third one. Pi minus pi gives us 0.
Oh,
Yep.
Negative pi over 2.
Negative pi over 2. And the fourth one now? What's 3 pi over 2 minus pi? Yep.
Pi over 2.
Pi over 2. And the last one, 2 pi minus 1 pi, just 1 pi. Okay, so that's it for the x's. X's are done. 1 point for each x value you get right in the table. All right, now the y's, both the 3 and the negative 2 are going to affect them. Which one do we do first? Yes.
3.
Yep, and what are we going to do with the 3?
We're going to multiply all of our original y values by.
Okay, so we're going to times by 3. And after we times them all by 3, what do we have to do? Yep.
Subtract 2.
Subtract 2. Okay, so my new y values are going to be negative 2. 3 minus 2 gives us 1. 0 minus 2 is negative 2. Negative 3 minus 2 is negative 5. And 0 minus 2 is negative 2. Okay, so there's your table. Any questions on that? Now we need to graph it. What I'm going to do is, I'm going to move this down so I have more space. Okay, so we need 2 x values that are in the negatives, so negative pi over 2. So let's do negative pi over 2. The axis is at 0. And then pi over 2 and pi. Now for the y's, I need to go up to 1 and down to negative 5. So what I should probably do with my labels is I should have put them above the axis, because then I won't be drawing over them. So what I'll do is I'll just move my grid. Now they're above the axis. Okay, so y's. Just go by ones. Okay, so we've got, this will be 0, 1, 2, negative 1, negative 2. Okay, I just moved my labels over enough so they wouldn't be in the way. Okay. Any question on how I set up my labels? All right, let's do our sketch. So we've got negative pi, we're at negative 2. So negative pi, negative 2. Negative pi over 2, we're at 1. So negative pi over 2, 1. What else? 0, negative 2. Back down there. Let's see. Pi over 2, we're at negative 5. So pi over 2, negative 5. And pi, we are at negative 2. So pi, negative 2. So because I didn't scale my axes, you can tell that this one has been stretched. All right. There you go. That's the sketch of the first cycle. Any questions on that? What's the amplitude of that sketch? Yep.
1.
No, not 1. Yep.
3.
3 is the absolute value of the number that's in front of the function. Or if you draw in the center line, which the center line is right there, it's the distance from that line to the highest, which is 3. Or that line to the lowest. It's also 3. So amplitude is 3. What is the highest y value we get? In other words, what's the maximum?
1.
That's 1. Yep. And what would be the minimum? What's the lowest y value we get? Yep.
Negative 5.
Yep, negative 5. And we'll do one more thing. What's the period of that? Yep.
4.
What's the formula you use to find the period?
Oh, 2 pi over b.
Right. For a sine or a cosine, it's 2 pi over b. And what's the b value in this case?
It's just 1.
It's just 1. There's only a 1 in front of the x. So the period would be
2 pi.
2 pi. Yep. Okay. All right, for the next question, we're going to take a look at 3 graphs that were given, and we're going to match them to the equations. All right, let's start by looking at the first graph. If we look at the slope of any of those curves, what kind of slope is that? Yeah.
A negative slope.
Right, negative slope. And we haven't done any reflections. So there's nothing tricky in terms of, oh, well, it could be this one flipped. Nope, there's nothing flipped here. Which graph, tangent or cotangent, always has negative slopes? Yeah.
Cotangent.
Cotangent. So since there's only one choice for cotangent, and there's only one graph up here that has negative slopes, the first graph, A, has to match with y equals cotangent x. Okay, so that relies on knowing what the tangent and the cotangent look like. Cotangent always curves down into the right. Right. Now, if I put some up with reflections, that could be a little bit trickier, but you can still use the calculator to graph each one of them and basically get an idea of what they look like. But we're not using the calculator on this one, so that's why I tried to make it easier. The next two are both tangents. How are we going to identify the difference between 2 tan x and 0.5 tan x? What is the 2 versus the 0.5? What is that doing? Yeah, Josh.
Stretching and shrinking,
Which way?
up and down.
Yeah, so this is vertical stretch or compression. Which one of these is a bigger vertical stretch? The first equation or the second one? Yeah. No, the second one is a compression.
Yeah.
So it's not as big, it's not stretching it, it's actually compressing it. So this one, 2 tan x, is going to stretch it more. Right? It's going to be a bigger stretch. Which one of the two graphs that we have left is more of a vertical stretch? B or C? Yeah, B. Because if you have a graph and you take and you stretch it vertically, what starts to happen to it is the curve, it doesn't go away, but it starts to smooth out. Okay, so the more stretching you do, the less the curve you see. So that means B is the graph that looks more stretched, and C is the one in the middle. The more compressed I make it, the more pronounced I could make this curve in the middle. So any questions on matching up an equation to a graph? Okay. All right, so the next question we'll look at is solving a trig equation. For this one, we're going to round to 2 decimal places. And it's 0.3 equals cosine x. And they give us a specific interval to solve it over. All right, so we want to solve this one graphically. How would I solve this on the calculator graphically? What's the first thing I would have to do? Any thoughts? About Benjamin, what do you think?
Can you repeat the question?
So I want to solve this graphically.
Go to y equals.
Okay, so go to y equals, and what would I do from there?
Put in cosine x.
All right.
And then go to another and put 0.3.
All right, so we got that. Okay, after we put everything in y1 and y2, what do we have to do next? Yeah?
Go to the window.
Yeah, we got to look at the window. What do you want to set? What did they tell us to set for the window? Yeah.
0 to 2 pi.
All right, so the x min is 0, x max is 2 pi. All right. What should I do now? Yep.
Hit graph.
Okay, I'll hit graph. Right. Yes.
Change it to
I'm
radians.
in the wrong mode. I'm in degrees. They told me x has to be between 0 and 2 pi, and they didn't put a degree symbol on it, so that's radians. So if you get a graph that looks like that, and it's not a wave, you're probably in the wrong mode. Now, it will look perfect. Okay, so there's my graph. I can see everything I need on the screen. What's my last step? Yeah.
You have to calculate the intersection points.
Yep, we're going to calculate the intersect. And the first time you do it, if you hit enter, you'll get one of them randomly, whichever one the cursor was a little closer to. Now, when I do the second one, do I have to be careful so that I get the one to the right? How do I make sure I get the one on the right now? Yeah. Marin?
Move it so that it's close to the one on the right.
Yeah, move your cursor closer to the one on the right. That should do it. And that's our second answer. So there's the two answers. You write x equals 1.27, x equals 5.02. Now, are those exact answers or are those approximate? Yeah.
Approximate.
Yeah, they're just approximate. They're not exact. You wouldn't be able to get exact for a problem like that one. All right, let's try another solve. But this time, instead of rounding to 2 decimal places, I want to get an exact answer. try y equals, well, actually we can't do that. Let's do 1/2 equals, and let's do sine x. Okay, so we're still going to start out the same way. Put everything in y equals. So we've got 0.5 sine x. Let's use the same window, 0 to 2 pi. Hit graph. Okay, and how many answers do I get per cycle? Yeah. 3? Can you explain to me where they are?
At the intersections.
Okay, where are the intersection points for the red and the blue? Or why do you think there are 3?
Because you can't see the full picture.
Well, we're seeing as much as they want us to see, because they said to only look between 0 and 2 pi. So we are looking at what they said. How many intersection points are there between that horizontal line and that trig function in general? Yep.
2.
So no, I'm thinking in general now. Like if I were to zoom out. Right, there are infinitely many. Even there's a lot more off the screen that we can't see. But we don't care about what's off the screen. So the only ones I can see on that screen are 2 answers. Okay? Now I want to find these as exact answers. So let's try to do second calc intercept. And I get I get that, 2.61799. If I write down that decimal, is that going to be an exact answer? That's not exact. So, what do? I want an exact answer, which means no decimal. Yep.
Don't you have to like turn into degrees?
Okay, so yeah, let's do the problem in degrees instead. What would I have to do to get this set up for degrees?
Switch it to degrees?
Okay, so I can switch the mode to degrees. All right, that's done. What now?
Multiply the 1/2 by the pi equation.
You don't want to modify any of these, because if you change this, you're changing the original problem. We can't change the 0.5 and the sine x, because that's what they gave us.
Would it be the window?
Okay, so let's go to the window. And what should I change my window to? Yeah.
Change the x max to 360.
Right. It should now be going 0 to 360. Any question why I had to change that to 360? Okay. If you've done this correctly, you should look at exactly the same picture. But when we find the intersect this time, instead of getting that decimal that I got before, I get a nice number. It's 150 degrees. But I still want the answer in radians. This is what I have right now. What can I do to get that into radians? Yeah.
Multiply by pi over 180.
Multiply by pi over 180. And what will that reduce to? 150 pi over 180.
5 pi over 6.
5 pi over 6. That is an exact answer. That is not a decimal. If I typed in 5 pi over 6, what do you think I would get as a decimal?
The number we started with,
Which was,
2.6 was.
yes, that is that number. So you're not going to be able to memorize every single decimal and what it converts into. That's not what you want to do. You want to graph it in degrees, get the answer that way, and then change it back to radians. That's how you get the exact answer. Any question on that? Yeah?
Should get the calculator to go from radians to degrees?
Like changing the mode.
No,
So,
like how did you make it look the same?
so go to mode and change it to degrees first. And then go to window and put the X max at 360.
Okay.
All right, let's do the other one. I don't have the other one as a decimal, but that's fine. I don't need it. In degrees, it is 30. That's the other answer. What would 30 degrees be in radians? Yeah, pi over 6. So if you kept your calculator in radians and you did this problem and you found the intersect, you would have gotten a decimal of something like 0.5235, which is not an exact answer. All right. Any question on how to get an exact answer in radians by doing it in degrees first? So next one we're going to look at, this would help us when we're doing a graphing problem, is finding the asymptotes. To find the asymptotes of a trig function, we have to first know what the asymptotes would be if we didn't do any transformations. This has a transformation, so it's going to change the original asymptote. Everything here is going to be compressed by 3. What is the first positive asymptote that we get to in a tangent graph?
Is it 0?
How do we write tangent as a fraction? It's what over what? Yep. It's sine over cosine. And a vertical asymptote happens anytime you get a what in what part of the fraction? Yeah.
A 0 at the bottom.
0 in the bottom. So we just have to figure out when is the bottom 0. Cosine looks like this. When is the first time that cosine crosses the x-axis? Yep.
Pi over 2.
Pi over 2. That is the first asymptote that I'm looking for tangent. Okay. So if I didn't do any transformations, the asymptote would be pi over 2. But because we've done a compression by a factor of 3, we need to set the asymptote equal to the argument and solve. How do we get rid of that 3 that's in front of the x? Yeah.
Divided.
Yep, we could divide by 3 or multiply by 1/3. I'm just going to think of it as timesing by 1/3. That's gone. Timesing by 1/3. So that asymptote that was at pi over 2 is now compressed in to pi over 6. It's 3 times closer to the y-axis than it was before. All right, so now that's the first asymptote, and that one is going to repeat every cycle. So we need to put something on the end indicating it repeats. What do I have to find that's going to help me know how often it repeats? Yep,
The period.
I need the period. What's the formula to find the period of a tangent function? Yep, pi over b.
Yeah, you're right, she did it.
And what's b in this case? Yep, 3. That is the period. So the first asymptote has been squished to pi over 6, and that's going to repeat every pi over 3. Every multiple. That's how you find your asymptotes. All right, so the next couple problems we're going to look at is just plugging in an inverse trig expression on the calculator and evaluating. I do want to do that in radians. The first two we're going to round. The last one, I'd like to get an exact answer. Okay. So let's go to radians. And how would I type in the first one? Inverse sine of 0.3. Yeah.
Second.
Yep.
Sine.
Perfect.
And then 0.3.
0.3. So the first answer is 0.3, depending, I'll tell you the decimal places on the test. Let's just say 0.305. All right, how about the second one? Inverse cosine of 0.56. How do we do that? Yep.
7 cosine 0.56.
Okay, and we get 0.976. Any questions on the first two? All right, now those are approximate. The last one I want exact. Let's try it the way we did the first two, and let's just see what happens. How would we type in inverse tangent of 1? Yeah.
7 tangent 1.
Okay. Now, if I write that down, 0.785, is that exact? No, it's a decimal. How am I going to get this as an exact answer? Well, what do we usually do when I ask you to find something as an exact answer?
Would you go to degrees?
So let's go to degrees. Let's type it in again. If you have to retype something, you can just press second enter, and it'll automatically bring up the last thing you typed. If you don't want to retype it, just saves you a couple seconds. 45 degrees. So I got a nice number. How am I going to get that into radians? Yeah.
Multiply it by pi over 180.
Multiply by pi over 180. And when we reduce, what's that going to reduce to? Yeah.
Pi over 4.
Pi over 4. Now, if you check pi divided by 4, watch what it comes out to. 0.78539. That's exactly what we got when we did it in radians, but it wasn't exact. So again, would I expect you to memorize that 0.785398164 is pi over 4? No. The point is you do it in degrees, you change it by hand, and then you'll get the exact answer. Any questions on that? All right, so for this one, they're asking us to find all 6 trig functions of theta. They are not asking you to find theta. The answer to this is not how many degrees or radians this angle is. We have to write all 6 trig functions. That's the answer. Okay, before we can write all 6, what are we missing that we have to find? Yep. Right, we don't have the hypotenuse, we have to find it. We know 2 of the sides, so how do you get the hypotenuse? Yep. Pythagorean theorem. So 5 squared plus 2 squared equals c squared. That's going to be 25 plus 4, and then take the square root. When you're doing a problem like this, the directions are most likely going to say exact. Don't round the square root of 29. If you have any question on the test, I would tell you it's okay to round or it's not okay. This is not okay. Leave it square root 29. All right. And because we have a square root, anywhere that the square root ends up in the bottom, we need to fix it so it's not in the bottom. Okay, so let's start with the sign. What would the sign of theta be in our picture? Yeah.
2 root 29 over 29.
Yep, it would be opposite over hypotenuse, so 2 over root 29, but then we fix the root 29 in the bottom. So there's the sign. How about the cosine? Yep.
5 root 29 over 29.
So 5 root 29 over 29, good. And what about the tangent? Yep, Megan.
2 over 5.
2 over 5. Now that we've got the 3 on the left, what do we do to them to get the 3 on the right? Yeah. Yeah, we're going to flip them. So to flip this, it's easier if I think of the original version before you fixed it. It was 2 over root 29. So this is root 29 over 2. What would be the secant? Yep.
Root 29 over 5.
Root 29 over 5. And the cotangent, 5x. The way the question will be set up on the test is I will ask you for one of those 6. I'm not going to ask you for all 6 in the same question. So it might say find the tangent of theta. Okay. And actually, if it said tangent, you wouldn't have even needed to find the hypotenuse because I gave you opposite and I gave you adjacent. So you might not even need Pythagorean theorem. But if you do, that's how you do it. Okay, so the next question is solving a triangle where they give us 2 sides. So they've given us A and B, which is the 3 and the 4. And we'll make our chart and figure out everything that we don't know. Okay, so we've got A. They gave us B. C, I don't know, so I'll put a box around it. Alpha, I don't know. And beta, I don't know. So the right angle, I'm not going to worry about writing that because I already know it's not. Right, let's start with C. If we know 2 out of 3 sides, how can I get the third side in the triangle? Yeah.
You can use Pythagorean theorem.
Right, you could use Pythagorean theorem. And can you tell me what the equation would be to find C with the information that I have?
3 squared plus 4 squared equals c squared.
Good. And when we solve here, we're going to get 9 plus 16, which is 25. And what's the square root of 25? Yeah, 5. So this is a 3, 4, 5 right triangle. Okay. Any question on how we got C? All right. Now we need to find alpha and beta. Which one do we want to do first? Yeah, alpha. Okay, so we're going to use this as our reference angle. We're going to use this because it was given, and that. Don't use C because it wasn't given. If it's wrong, it messes everything up. Okay. What is the position of the side that's 3 units long in this triangle relative to alpha?
Opposite.
Opposite. What about the side that's 4 units long?
Jason?
Adjacent. Good. So opposite and adjacent are the two sides we know. What trig function has opposite and adjacent in its definition?
Tangent?
Tangent. Yep. So let's find alpha. So that's how your equation always starts out. Trig function equal to a fraction. What's the argument to my trig function? Alpha. It's the angle. So fill that in. And what's going to be the fraction on the right side? Yeah,
3 over 4.
3 over 4. Okay, we've got a variable inside a trig function. We need to get rid of tangent. What function cancels out of tangent? Yep,
Inverse of tangent.
inverse tangent. So remember, there's no arithmetic. We're not multiplying, dividing, adding, or subtracting. We are taking the inverse tangent of each side. So we're going to do this. And just try to fit it over there. Inverse tangent and regular tangent. What's going to happen to those two? Yeah.
They're going to cancel.
Right, they cancel out. So we're left with alpha equals, and then we have to do inverse tangent of 3/4. Okay, so we get an angle of 36.8. That's going to round up to 36.87. 36.87. So now we've got alpha. We would find beta the same way, but we'd be switching our perspective. Beta is up here. So what would happen to the opposite and adjacent now?
They switch.
They would switch. Right? And then you do the problem again, relabeling it just like we did for alpha. Any question on how you would finish that up for beta? Okay, so just be inverse trig one more time. All right, so last question. Just like the one we did with given the two sides, except this gives you a side and an angle. What can you find first pretty quick in the problems where they give you a side and an angle? Yeah.
Beta.
Right, whatever the other angle is, you can get it pretty quick. What would the angle be for beta in this case? Yeah,
70 degrees.
70 degrees. Okay, so we know that the two acute angles are complementary, so they have to add up to 90. All right, so we've got beta. Now we can find B or C. Alexis, which one do you want to find?
B.
B. So I'm going to circle B, because that's what we're going to try to find. And what angle do I want to use as my reference angle? I have two angles to pick from. Yeah.
Alpha.
Yeah, we're going to use alpha because
It's the given.
it's the given. Yep. And one other piece of information that I want to use, that I need to use. Travis?
The 7.
Right. Always use both things that were given and then choose what you're trying to find. Okay. What position is the 7? All right.
Opposite.
Yep, opposite. And Eileen, what about the one we're trying to find? B.
Adjacent.
That's adjacent. So we know opposite, we want adjacent. Which trig function has those two? Yep,
Tangent.
tangent. All right. Can anybody finish filling out my my equation to find B. Yeah.
Tangent of 20 degrees equals 7 over
7 over B. And Nora, do you remember the trick we can use to get B by itself there?
Multiply by
Well, you can then multiply by B and then divide by something, but there is a trick so we can avoid that, and we don't have to do it every time. Does anyone remember what the trick was? Yep.
Just put the B on the opposite side and swap it with the tan 20.
Right, all we have to do is switch these two things. Okay, and in class I explained why that works, but just switch those two. So we've got B equals 7 over tan 20. Okay, we will generally round to 2 decimal places. If it's different, I'll say the directions. So 19.232. Let me write that answer. Okay, so now we've got B. You would find C the same way, except you'd be using hypotenuse and opposite. Which trig function has those two? Yeah, sine. So to find C, you would use the sine. But it would be the same steps that we just did. You never switch your reference angle in this kind of problem. Only in this kind